everybody, we're getting ready to do lesson 3.1 today of pre-calculus, part 1. And it's a 62-point classwork lesson. There are 0 points of note-taking today. And teachers, here is the bell work for this lesson today. Compositions of functions, composition of functions, and give your students 7 minutes to do these 2 problems. Okay, welcome back. Here are solutions for today's bell work 3.1 and A. F of g of x equals f of x cubed minus 5 g of x. So that would be the cube root of, and then we insert this into our x here, x cubed minus 5 plus 5, and that turns out to equal x. And then for b, g of f, in this case here, g of f of x, and g is the cube root of x plus 5, which equals the cube root of x plus 5 cubed minus 5. Again, that equals x as well. So that means that they are inverse functions of each other. And then number 2 here, f of g of x equals f of, and then the cube root of x plus 1 equals x plus 1 minus 1 equals x. Here, f of g of x. Then b, g of f of x equals g of x cubed minus 1 equals the cube root of x cubed minus 1 plus 1, again, equals x. Okay, on to our lesson today, exponential functions. In this chapter, you'll study 2 types of non-algebraic functions, exponential functions and logarithmic functions. These functions are examples of what are called transcendental functions. And then the definition of an exponential function. The exponential function f with base a is denoted by a to the x. Here, f of x would equal a to the x, where a is greater than 0, and a cannot equal 1, and x is any real number. So that would be a definition of an exponential function. Okay, so you've already evaluated a to the x for integer and rational values of x. 4 cubed and 4 to the 1/2 power is 2. Think of a to the square root of 2, where square root of 2 is 1.4142136, as a number that has a successively closer approximations, a 1.4, and then we extend out this decimal here as we get closer and closer to actually the square root of 2. So being able to use that as an exponent on functions, so use a calculator to evaluate each function as at the indicated value of x. So f of x equals 2 to the x, and in this case x equals negative 3.1. So if we go 2 to the negative 3.1, this will be your calculator entry protocol here, 2 uppercase negative 3.1 enter, and then you should get this number here, 0.11166291. And then for 2 to the negative x, when x equals pi, so 2 to the negative pi power, then this will be your entry protocol here, 2 uppercase negative pi enter, and then we get this number here, 0.1133147. And then f of x equals 0.6 to the x power, and in this case x will be 3 over 2. So 0.6 to the 3 over 2 power, this is your entry protocol here into your calculator, 0.6 uppercase And then we put 3 divided by 2 inside parentheses. And then we hit enter, and then we get this number here for 0.4647580. And then f of x equals 1.05 to the 2x power when x equals 12. So 1.05 to the 2 times 12 power. And then we'll do that in our calculator entry, 1.05 uppercase, open parentheses, 2 times 12, close parentheses, and then hit enter, and we get 3.2250999. So that is evaluating some exponential functions using a calculator. Now, into our guided practice here, evaluating exponential functions. Use a calculator for these. G of x when x equals negative pi. And then down here for you, your independent practice, 8.6 and negative 3x when x equals the negative square root of 2. So for a guided practice up here, 5 to the negative pi power would equal approximately 0.006. Another example here, example 2, graphs of y equals a to the x. In the same coordinate plane, sketch the graph of each function by hand. Okay, so we have f of x equals 2 to the x, and we have g of x equals 4 to the x. So we should have a table here. You should make a table for each of these. So when x equals 0, this is always a great place to start here for all of them. When x equals 0, for both of them, y would equal 1. So you'd plot that point there. And then when x equals 1, in this case, y would equal 2. And then in this case, it would be y would equal 4. So x equals 1, there's your 4. Then here's your 2. Plot those. And then when x equals negative 1, 1/2 and 1/4, plot these over here. And then go out a little bit further here to when x equals 2. In this case, 2 to the x would equal 4, and then 4 to the x would equal 16, which is way up here. So that would be how you plot them by hand. And then you could check yourself with a graphing calculator. 4 to the x is increasing more rapidly than the graph of f of x equals 2 to the x. Because this is kind of like your slope here, and it's definitely going to increase more than 2. Okay, to our next problem here. Graph the exponential function by hand. Here's your table here. Identify any asymptotes and intercepts, and determine whether the graph of the function is increasing or decreasing. So this is your independent practice down here. We're going to do this in our guided practice here. So a to the x and y equals a to the negative f, not a to the negative x. We haven't gotten to that yet. So let's do this one here. Graph the x. Well, we could compare these to y to the a to the x, and then y equals a to the negative x. But let's graph 3 to the x. Okay, so here's a box here for x equals 0, y equals 1. When x equals 1, y equals 3. Then when x equals 2, y equals 9. When x equals negative 1, y would equal negative 1/3, or rather 1/3. So over here, so the thing's going to go like that. So our asymptote would be the y equals 0 or the x-axis. Here is your asymptote here for this. And then you have a y-intercept here at y equals 1, 0, 1. And it's increasing because it's going up from left to right. Okay, off into example 3 here. What we're going to do now is to graph y equals a to the negative x. So we're going to have a negative exponent here. F of x equals 2 to the negative x. We graph that. And then graph g of x equals 4 to the negative x. So we got negative exponents. And then these are our tables here that we're going to use to plot, because we're going to do it by hand. So here are x equals 0, y equals 1, negative 1, and then 1 over here. So we got a different situation. We got something like this, looks like. So both graphs are decreasing now. With these negative exponents, both these graphs are decreasing like that. The graph of g of x equals 4 to negative x is decreasing more rapidly than f of x equals 2 to the negative x. So this graph here is a 4 to the negative x. The 2 to the negative x is a flatter graph. So I've got to practice. 3 to the negative x, graph that. So I'll guide you through now. And then yours is 10 to the negative x. Here's your table for that. So up here, 3 to the negative x, here's our table. Graph, this is showing 5 values here of x. You don't even really need that. Yeah, that's nice though. 0, 1, 1 is 1/3, and 2 is 1/9. So down here, we need to show asymptotes and intercepts. So when x equals 0, y equals 1, so you're going to have an intercept there. So this is what your graph should look like, plotting by hand. Should look like that. So it is decreasing from left to right. And then your asymptote is y equals 0, which is your x-axis here. That's your asymptote. And then your intercept when x equals 0, y equals 1. And it is decreasing. So now you graph 10 to the negative x. Okay, moving on. So the properties of exponents can also be applied to real number exponents. So for review, these properties are listed below here. So we have a product of exponents here is when you add, and then you have your quotient property here, and you have your negative exponent property here, you have your zero property of exponents, then you have your product powers exponent property, same thing here, product powers, and then another product of powers here, and then you have your absolute value of exponents here. You bring in your absolute value bars here. You put your base inside the absolute value bars. So comparing the functions in examples 2 and 3, observe that 2 to the negative x equals f to the negative x, and g to the x equals 4 to the negative x would equal the same thing as g to the negative. So consequently, the graph of f is a reflection in the y-axis of the graph of f. As shown, the graphs of g and g have the same relationship as shown. So this is 2 to the negative x, and then 2 to the x. This is what they would look like here. And then g, capital G and lowercase g, 4 to the negative x, 4 to the x. Kind of the same thing here. The parent exponential function f of x equals a to the x, a is greater than 0, and a cannot equal 1 for this function here. So this is f of x equals a to the x. You have a y-intercept here of 1. And then so this describes this here, your domain, your x values here go to negative infinity and positive infinity. Your range is 0 to positive infinity. Your intercept is 0, 1. It's increasing on the negative infinity to positive infinity interval. The x-axis is your horizontal asymptote here. And then a to the x as it goes to 0 as x goes to negative infinity. So this is your negative infinity down in this direction here. And so your a to the x value here as you go further to the left will approach 0. And it is continuous. It is continuous. And then a to the negative x. We got something of the same thing here. a to the negative x. The difference would be it's decreasing now. From negative infinity to positive infinity, it's decreasing instead of increasing, where the other a to the positive x would be increasing. X is your horizontal asymptote, and then as a to the negative x approaches 0 as x approaches infinity. Just saying that as you go further this way, your a to the x value decreases, and it is continuous. Okay, into our next example here. Example 4, library parent functions. Each of the following graphs is a transformation of the graph of f of x equals 3 to the x, because g to the x equals 3 to the x plus 1, which is this one here. We're moving to the left here 1 unit. The graph of g can be attained by shifting the graph of f 1 unit to the left, so we're moving this position here over to the left 1 unit. And because h to the x equals 3 to the x minus 2, this graph here, the graph of h can be attained by shifting the graph of downward 2 units. So we're shifting down 2 units here for this function here, 3x minus 2. So we're going down. That's your shift there. Because k to the x equals negative 3x, this is our situation here. This is our parent here. F of x equals 3 to the x. So this is k to the x is the negative of 3 to the x. So it is a reflection here in the x-axis for this function here by reflecting the graph of f in the x-axis. So it's a reflection. And then we have j to the x equals 3 to the negative x. So this is our parent here, 3 to the x, and then this is 3 to the negative x. So when you put them on the same axes, you can kind of see the difference there between what happens when you put a negative sign in this function. Okay, our guided practice. F of x equals 3 to the x, g to the x equals 3x minus 5. And then this is yours down here for you to graph. Use your table. We're going to do this one now. The graph of g of x equals 3 to the x minus 5 is a horizontal shift 5 units to the right. So here's our parent here, 3 to the x. And then 3 to the x minus 5, you shift to the right 5 units, then you start your increase here. So your point here, when your y value equals 1, it would be over here at 5. That's your horizontal shift there between these two functions. Here, 3 to the x minus 5, and then 3 to the x. And that is your 2.1 part 1 pre-calculus. Contact me here if you need information. Thank you.